I used to have to try to tell people about mobile devices and mobile apps are important. I really don't have to do that today, these days. I think everybody gets it. We've got, almost 8 billion smartphones, quarter of a billion, 250 billion mobile app downloads every year. And on average, people have 60 to 90 apps installed. So we know that apps are used not only personally, professionally, in our civic lives. They're used everywhere. Mobile flaws are challenging to detect for three primary reasons. So the first one is that Apple and Google, built mobile devices from the ground up, learning, taking everything that they learned from desktops and servers, and by default, we don't have root access. And so as security folks, that is a huge problem for us because we need to be able to inspect the operating system, the file system, everything that's going on. And so when they put in these platform restrictions, it's great for security and privacy, but when there is issues or if you can't detect them, it's a real problem for defenders. So app sandboxing, et cetera, we just don't have a lot of security and privacy APIs. The second thing about mobile apps is that they're actually much broader than web apps. Inside a mobile app, many of them have an actual full browser instance that's running that developers delegate control to. So instead of just having all of the bespoke things that are new and novel about mobile apps, all of the sensors, we also have the full kind of web app attack surface. And then there's a lot of third-party SDKs that are being used. Some of them are closed, some of them are open source, but really mobile is kind of built on top of SDKs are doing about 60 to 70% of most mobile apps. And then there's constant change. Apple and Google on a yearly basis are updating them. Not just the operating system, but the frameworks that we rely on. And so we support a couple of large open source projects and have for over a decade. One of them is called Frida. Some of you may know about Frida. So Ula has worked for us for over a decade. And every time a new version of iOS comes out, which is his primary focus, or Android, a lot of times we have to redo some of the primitives and fundamentals in Frida to support the latest OS. So when you put these three things together, it just becomes really challenging to go out and test mobile apps in the way that we're used to on web apps. Why does this matter? Well, attackers are able to collect an enormous amount of information off devices. We know that there's a lot of sensors, there's a lot of telemetry that comes off of these, so we have security and privacy issues. And I mentioned a minute ago, we lack that same visibility. So if somebody is successful in compromising a device or an application, they have the ability to see everything, and we have virtually no telemetry coming off of it. So how do we detect it? How do we know there's a problem? The short answer is we don't in most cases. And I think these impacts are significant. I think they're significant not only to the businesses that you work for, maybe it's fraud, maybe it's a breach that causes lots of issues for you, but it impacts us personally, right, as our information gets scooped up. And there are implications, especially as we think of things that are happening at a geopolitical level, from both a national and economic security standpoint, theft of intellectual property, data collection of U.S. persons at large. So there's a lot of reasons why this should matter. Now, the reality of it is that most people don't think about this. And they assume that most applications have been tested and vetted. And really my goal out of this would be, I'm going to tell you the top 5. I'm going to show you examples in the real world of how they're manifested, but really to get folks to think about, like, if you think that app's been tested, it probably hasn't, or it certainly probably hasn't to the extent that you think. So what did we do? We've built for over a decade now, maybe 12 years, we've been building out automated mobile app security testing, both static and dynamic. So we'll reverse engineer the binary using Radare, which is one of our other really big open source projects. That's a open source reverse engineering framework. And then we'll use dynamic analysis, and we test thousands of them a day on behalf of customers. But a lot of what we do is crawl to stores and test the publicly available apps in every new version. And so we have millions and millions of assessments, and we break them down and we look into risk in kind of broad categories. A lot of different things. Fraud is something that comes to folks. So we have like delivery companies where people will reverse engineer the APIs coming out of the mobile app, figure out how to effectively commit fraud against them. and basically just using the app against them. There's emerging technologies with AI. We've already kind of touched on privacy, et cetera. So really mobile's big enough that all of the traditional areas that would drive risk into a business are present. So my goal today is to take you through the top 5 issues that we've seen from these hundreds of thousands of assessments. I'm going to go in reverse order, just like the last talk. The first one I want to talk about, and people don't think a lot about, is reconnaissance. If you have a web application, it's going to be likely deployed on a web server in front of a WAF, with a firewall in front of it and Cloudflare or something like that, right? You've got layers of protection. When you ship a mobile app, you ship it out to play in the App Store. The entire app binary is accessible to the device as well as to an attacker. And they can and they will reverse engineer the app. There's open source tools that will do that. Our tools will do that as well. So there's an enormous amount of reconnaissance that can happen inside mobile apps that people are not thinking about. And so the general structure here is I'll give you the top 4 or 5 findings that we have. We have like 460, 470 findings that we test for when we do an automated scan. So I kind of pull out the top 4 or 5 that might be interesting and give you a frequency. I'm going to pull out one then on the side and kind of walk you through it. And then I'll take you through 1 or 2 examples for each of these of how they manifest in the real world. So the one that I pulled out here is debug symbols. This is super helpful for, yeah.
Quick question about this statistic.
Yeah.
Do you have by any chance percentage of mobile applications that were protected by obfuscation?
Yeah, we actually do have that. So one of the things is we've built in heuristics. So we kind of play a cat and mouse game with 2 primary actors besides the attackers. We play a cat and mouse game with Apple and Google because they're constantly changing. And we play a cat and mouse game with RASP providers. So because we have root on these devices and we use Frida, we are able to hook a lot of the functions and effectively detect RASP. What I'll do is either live or after the call, I'll go into our findings and look at our RASP finding. I don't have it as a pivot and a breakout on this one, but we do have those statistics, and I can provide you the breakdown on RASP. We are seeing RASP increase. I would say we defeat 98% of RASP, and then they'll do their next one, and then we have to decide if it's worth defeating it, automated. We will, like an attacker, because we have root, we will always win. But there's a level of effort, and they've gotten better, and so depending on what level of RASP is being deployed, it can have an impact on these things. So debug symbols. So debug symbols are super important for developers, right? So you've written your code, you've pushed it, and you need to be, and there's obfuscation, and there's the compilers come into play, and you need to be able to say, look, I had an issue, where's it at in my code? So you bundle up debug symbols and maps of the source code inside the application. Now, when those get bundled in and an attacker gets their hands on it, they have a really great way to view out your entire application and what's going on, even if it's been obfuscated or otherwise other RASP techniques. So we find debug symbols in about 72% of apps that are out there. Why? Because the compilation of mobile apps is a complicated process, very complicated, lots of moving parts, and people don't think about it. And so they just get bundled in all the time. These are some of the other ones that we see. API discovery, we will routinely map out all of the APIs that your application is using. And we'll look at it like, oh, these are the third-party APIs, but here's the ones that you guys are calling as part of your application. Hard-coded URLs, et cetera. So let me give you a real-world example. I think I have 2 of them in here. This is an alert that came out from CISA a couple of months ago. My security account app. It's largely used by industrial, by businesses and industrial controls, and it allows you to look at all of the different alarm systems and things that are deployed at an enterprise. If you reverse engineer the app, you'll see that inside there they have an API call where they'll simply pass along the a numeric ID, I believe, for the installation that you have. And if you do a BOLA attack or simply increment the ID, you're able to just go through the entire account list. So this came out as a vulnerability. It came out as an alert from CISA. It was being actively exploited. And And it was very easy to accomplish this just by reversing the app, looking at that structure of the API, and just changing the integer and seeing what happens. Another example, and this is kind of the flip side, this is actually a piece of malware called SparkCat. The developers put it out there, samples were collected, and if you look through the debugging symbols, you can actually see really interesting things, and we see this all the time. Like you could see the names of the developers show up because those are artifacts that happened during the compilation. You could also see the C2 system that they were using and what they named it, and then like how they originally named the application. They called it gzip. It's kind of interesting, right? Like if we think about some of the open source or vulnerabilities and attacks that have happened, naming something like gzip originally, they renamed it later, is interesting because you can see they're trying to figure out how can they hide this in kind of inside the infrastructure, live off the land, et cetera. So these were just kind of a couple of interesting examples where you can use reconnaissance in mobile apps to find a lot of interesting information. The next one is encryption flaws. Encryption's hard. People get it wrong all the time, and we see that commonly in mobile apps. The one that I chose here is that the app's encoding sensitive information with some sort of outdated or insecure crypto. So this in particular, we're not looking for you're just using outdated crypto, but it's actually a sensitive value. So we track like 15 or 20 different things. It'd be sensitive username, password, PII, GPS locations. And so if we see applications that are using insecure crypto or outdated, we'll flag that. And so that shows up in an enormous number of applications. People are using just encryption that's out of date or insecure, improperly initialized. We see a lot of initialization vector reuse or static values being passed through for keys that are hard-coded into the application. So I wrote about this in February of this year, and we got quite a bit of press. This is right after DeepSeek pushed out their model, and over the weekend it became the #1 app. And then I think U.S. markets lost about $2 trillion in market cap. Everybody freaked out that the Chinese had figured out a better way to do AI training and models. They haven't. I'm sure you guys followed that. There was a lot of borrowed training that they did. But that particular application, we decided to do a deep dive and just to see whether or not there were any issues, and there were. So this is out on our website. You can go check it out. I highlighted one of the findings here. First of all, they were sending sensitive data over the internet without any encryption, so that's a problem, complete lack of encryption. But they were also using triple DES, which is an old crypto algorithm. And they had actually hard-coded the encryption keys inside the application. So we found a whole bunch of different issues inside the application. We've got a nice little write-up if you want to see that, but it's just a real-world example of an app that we did a disclosure on with weak crypto or outdated crypto. Okay, the next one I want to touch on is untested third-party SDKs. I kind of hinted it at the beginning, but when we do static analysis on a mobile app, we can actually differentiate between code that you and your developers have written versus code that's coming in from third-party SDKs. We find between 50 to 60% of a mobile app is third-party SDKs, so a good percentage. We also see that a small percentage of the market is currently doing mobile app security testing with a specific bespoke tool. Most people either assume the app and Play Store are doing it, or they'll use traditional web testing. They'll use a Veracode or a Sneak or whatever, but they'll do static code analysis. And the problem is that when 60 or 70% of your code in your app is coming from some other place, you don't have the source code to you, that static analysis won't catch the problems. A lot of the issues we find in mobile apps ultimately originate from the SDKs themselves. When we started on this a decade ago, we started with our automated testing. We started submitting CVEs to MITRE for vulnerabilities that we found, and they literally told us stop, that they're not, even back then, budgeted to be able to support that number of inbound because we were finding so many issues. So the problem is that we find problems in SDKs all day long, and they never get a CVE. So if your strategy is, well, we'll wait and see, and if there's a CVE for this thing, you'll see 1% of SDKs, mobile SDKs that have serious issues will ever get a CVE issued because there's simply the budgeting and scale problem in that system. So,
but who is owning SDKs? Is it like companies like Google and Apple? Or?
It's a mixture about who owns it. Some of them are open source ones, and we'll know about them and we'll use them. Other ones are big companies, sure. And other, Crashlytics would be a great example. And then other ones will be smaller SDKs. We find the issue frequently with advertising SDKs. They're intended to collect a bunch of data. They're focused on doing it fast and efficiently, and they're competing in a very tight market, so cost matters. And so they tend to put things out that aren't super tested, that collect lots of data. They'll use weak crypto. They'll have different types of issues in there, and then that ends up affecting thousands of apps, which means typically millions to billions of installs. It's a problem that scales very, very quickly. So we find about 15% of mobile apps have SDKs with known vulnerabilities. A good example is this: there's a libpng issue that we see that pops up quite frequently, misconfigured networking, things of that sort. And we'll also provide the overall kind of software bill of materials. So if you're looking at an application, you can see what all of the SDKs are that are installed. So here's a real world example, and this one's kind of interesting. So there was an advertising SDK called PushWhoosh. It became popular because it was free and it was good. And that's all developers need: free, good, other people using it, sign me up. The problem is that, so they got on about 2.3 billion devices. And then they started having security issues and over-collection issues. And people began to dig in to this particular SDK. And it was represented as a US company. But when you did a little bit of OSINT and dug back, you found out that the folks that founded it were actually based out of Russia. And then they came over here, they changed the name of the company. And there's a really interesting article. I linked to it here. I can't remember what news publication did it, but traces what happened. And so basically the company set up fake offices. They created fake board of directors. They used people's pictures from LinkedIn. I mean, they were putting up a facsimile of a company. And in the end, became a very, very popular SDK. Now, we do a bunch of support for the US government. This application, or this SDK showed up in the Army applications, the Army Proving Grounds, federal agencies, et cetera, as well as a whole bunch of other applications that were out there. So this is just an example where a third-party SDK has an issue, and then all of a sudden it's everywhere, including places you wouldn't expect it. Yes?
How did they detect the over-collection?
Hit me. Yeah, I'm trying to remember what happened. I don't remember what happened on this one and how it got flagged. We didn't find this one. One of the things that we do, because we're constantly testing apps, is when it was found, we had some of our customers approach us and say, I'm using these 15,000 apps. Do any of them have PushWhoosh in it? And it was a simple matter of us doing just kind of a horizontal query, if you will. I don't remember the story behind what pinged it to the top. I think it was a security issue, and then people started looking at it closer. Again, afterwards, we could take a look. This is actually similar. Sneak found this one years ago from an advertising agency, again, advertising SDK called Mintegral. And what they found was that there was excessive data collection. Some of that was going out over HTTP, and they put out an alert about that and worked with them. But when they looked more deeply into the application, they actually found that there was a backdoor that allowed remote code execution. This one was based out of China. They became super popular, and then again, they made the change to the SDK after they were installed on billions of devices. Now, how often does this happen? It happens sometimes. Most of the issues we find in SDKs are just poor coding, things were overlooked, people weren't testing it. But especially if you work in sensitive areas and whatnot, there's also malicious activity going on. And again, developers are attracted to free, other people using it, and good developer documentation, and it works, will generally use it. So you need to be scanning these apps to make sure that these things don't happen. The second one is security misconfiguration. So just kind of typical things that you would see in any type of application, hard-coded keys. So again, focusing on cryptography, we find that people hard-code keys all the time in mobile apps. It could be Firebase credentials. It could be a crypto key, and they just hard-code it. And I think it's just a lack of knowledge of how do you securely implement these? How do you inject these in? What's the right way to initialize these things? So obviously hard-coded keys are bad. We don't find them in tons of apps, but we find about 20%. I mean, that's still way too many for hard-coded keys. Like we should maybe find it in 1% and whatnot. So we do find, we have a new finding that we started late last year because AI blew up overnight. We started in, I think, October or November of last year, and we now have 6 findings to detect AI, just so that people are aware of how is AI being used? Are you using it directly? Is a third-party SDK using it? And we found that now 35% of all mobile apps have some sort of AI baked into it. Most people don't realize that, but the apps that you use every day are going to have AI baked into it. We in particular check for people hard coding their AI keys, to the crypto keys like OpenAI and Anthropic and Claude, and we find that in a small percentage, but it happens. So these are just kind of examples of some of the findings that we have. So here's a real world example. This one is called the Cardio Health app for iOS. Again, this was CISA. Hopefully they will retain enough funding to keep these things going. And they put out an alert because the developer hard-coded the username and password to their entire backend system in a plist file. People went out there, they grabbed it, and they were actually able to then send hex-based commands out to heart rate monitors, live. So this is an example of, real-world example of hard-coded keys. And as I mentioned, we are starting to find, and I redacted it here, but that people are starting to hard-code their API keys. So they're probably quickly being pushed to get AI built into their app. They get something working, they need it in the app, they push it out there, and before you know it, the keys to all of your back-end AI system that you're accessing and using would be accessible. So here we find it 0.14%. So on this sample, it was 9,300 apps. It was only in 13 apps, but still concerning. And then the biggest one that I think, and I think this is the kind of pervasive risk that exists, is privacy issues. For a good example of this, and people don't think about it, is obviously PII is super important. Privacy is important. Your name is considered part of PII, and a lot of people don't realize that some of these libraries that we talked about earlier, like Crashlytics or any of them, they'll collect your device name as part of their analytics, and a lot of times, people on a iOS device, the name will automatically default to your names. Like if you don't go in there and change the name, it's going to say Andrew Hoog's iPad or whatever. So we find that an enormous number of applications are collecting PII, and that's okay if you disclose it. You probably should only do it if you need it. But importantly, you should understand where it's going, because you may be having a third-party library installed. It could be collecting very sensitive data and be sent out, and you haven't disclosed that. You weren't even aware of it. So now you've got your customer data or your sensitive information sitting somewhere else. So Apple and Google have been working on this for a while. Increasingly, they're requiring developers to include purpose strings or reasons of why they're requesting different things, and to provide attestations. And we find that 75% of the apps that we test are missing their purpose strings. So you request a permission, you need to say why, and about 75% of apps right now don't do that. We find a lot of apps unintentionally, we think, cache-sensitive data inside HTTP cache databases. This comes from what I mentioned earlier. A lot of applications bundle like a WebKit or a browser instance inside the application. They will automatically cache data for performance reasons. And then we end up finding that There were things that were being done in the application. The development or security team didn't realize it, and a lot of that sensitive data would be cached unencrypted on the device. We still find almost 3% of apps fail to properly validate certificates, and so have man-in-the-middle issues. This is just a real-world example. It's redacted, so it's not super interesting. I'm going to jump. I'm actually jump over here 1 second. When I talked about this at RSA, I was like, hey, we're going to be putting out a website soon where people can see this live. So if people are interested, we have a thing called mobile app risk tracker. And we've got, you can come in here and search. I think we've got 2,500 apps out there right now. Or you can just randomly pick one. And what we're doing is we're trying to show folks, like, we're not going to put any security vulnerabilities out here, but we're trying to put things that are facts, unequivocal facts about an application, and share that with folks so they're kind of aware of it. So this was the one that popped up when I loaded the site earlier. Let me zoom in to make sure you guys can see this. So this is, I don't know what it is. It's some sort of entertainment network. But we'll list off like all of the permissions. So you can see here this, the different permissions. To me, permissions is boring. I mean, it's been around forever. We know why they exist, but it's always good to say, okay, this is a news application, right? Does it need access to your local network, your camera, your photo library? I mean, you can make that assessment yourself. The privacy declarations that we were talking about. So here we can see that there are 4 different privacy declarations that they're missing. So they're missing the overall privacy manifest. They're accessing certain APIs that Apple requires. They're collecting data, and they're missing attestations around that. And then there's privacy. We see whether or not there's trackers being used in the application. So these are all missing from the application. And then we'll also look at like sensitive data that's being collected. So this one is collecting the ID for vendors. It's intended to be collected, but it hasn't been noted. And so, they have that kind of mismatch on the privacy side between what they collect and what they declare. And then we'll also look at network connections and their locations, so people can kind of get a feel for what's going on. And then this app does not have any AI built in. So if you're interested in checking, any of the apps that you use, you can go out there and look at 2,500, and you can get this. You don't have to have an account or anything. One of the things when I was prepping for this that I did not know, but there's this protocol called OpenRTB, real-time bidding. So this is how ads work. If you're on a web app or a mobile app and somebody's going to feed an ad to you, they put it out to a network of bidders. They have a couple hundred milliseconds to evaluate, make a bid, it gets awarded, and then whatever ad won the bid shows up on your phone or on your mobile app. And as I was evaluating this and trying to understand how so much data is being collected, what was interesting to me was the OpenRTB spec, which mobile apps use significantly, does not require HTTPS. And so people can sign up and be part of the real-time bidding network as like an advertiser, and you can collect, and you basically listen in on a bus, and you collect enormous amounts of data about people all around the world, and it's just happening in real time. And so it was a big eye-opener for me. The thing that clued me in on all of this was Brian Krebs wrote an article about the impact of app tracking and Apple's app transparency. So I don't know if you guys remember, but a couple of years ago, Apple came back and said, hey, we're going to require you to be transparent about tracking if you're tracking people, and you have to declare that. And Facebook freaked out and said, this is going to cost us tons of money. And Apple's like, yeah, like you're tracking people and you need to tell them. So they built it into the operating system. Everybody started freaking out. What's interesting, and maybe a little bit hard to see here, in Krebs's article, when they went out there and now look at the data that's out there that brokers are collecting and then selling, 80% of that data now is Android-based and 25% is iOS. Why? Because app transparency tracking is working. People get this little pop-up, do you want to be tracked? You're like, no, not really. Like that happens enough in my life. I don't want you, some random app developer, to go surveil me, so they mark no. And so app tracking transparency is working. Privacy is a big issue, and we have a long way to go. So that they started doing that in 2021 and had this huge impact on reducing how much of Apple users' data is out there. So Krebs did this analysis. He looked at a company, and there was they did an investigation of Babel Street, and this is an application. I don't know if I show a picture of it next. No, where you can go out and draw a map on a box on a map and say, show me every person's information that comes to this spot. And then you can click on a single ID and you can track them. Now, I don't know if you guys have looked into this much, but they say that it takes 3 or maybe 4 geolocation to pinpoint and precisely identify who you are. Why? We generally sleep at the same house every night. A lot of times we go to the same work. So they did things like, let me draw this box around where the jurors park at a courthouse. Let's go demask and de-anonymize who those people are. And so the short answer is like, billions and billions of data points are being collected on mobile apps. We know that. A lot of that's going over HTTP on the back end. I didn't know that. And these are then being scooped up by companies like Babel Street, who, by the way, when we posted our blog about this, because in DeepSeek or whatever, we got a cease and desist and takedown order and said, you have to take this down. And we were like, whatever, just go away. And we ignored them. So it's still out there on our website as well. So they're actively trying to go out there and saying, we don't do this, we don't do this. But check out the article. It's in my deck. It's a very, very interesting read. What does this look like in the end? I don't know if you guys recall, but Gravy Analytics had a breach. And so 17 terabytes of their data were pulled off of AWS Cloud. And you could see where was that data coming from. And the predominance of that data was coming from mobile apps. So Candy Crush, Tinder, Grindr, et cetera. I had used MyFitnessPal for a while to do the little calorie thing and track and how much protein are you getting and all that. Like that all feeds into this massive database of who you are and where you're located. And so to me, that was a big eye-opener on why privacy is so important. Okay, so why do we have all of these issues? Why are so many mobile apps have issues that I think arguably should not? I think one of the very first big reasons is a lot of people assume that Apple and Google are doing security and privacy testing. They are not. That's the short answer. They make $25, $30 billion a year on their apps. They want to block malware. If somebody's doing something really stupid, they want to block that, and they are not vetting apps past that, right? So if you work in security, if you're a developer, and you think, look, as long as we get past the Apple and Google scan, we'll be okay, you won't be. And I think as evidenced, all of the data that I was showing is coming from public apps. Some companies worry about the apps they build, which is awesome, and they invest in security. A lot of people don't think about the apps they use. So a typical company will have hundreds to thousands of apps that power their business, and information about your employees, your customers, your intellectual property, your financials, they're all scooped up in those apps. So all the issues that we talked about earlier impact also all of the apps that you use. And so it's something that I think people overlook and haven't put a lot of thought into that. And as I mentioned earlier, the folks that do, a lot of folks just don't test their mobile apps. If you do test your mobile apps, the most likely thing you're going to do is you're going to use some sort of web testing static source code analysis. It's going to miss all the third-party SDKs. It's going to miss all of the Kotlin and Swift and all the unique things about the ecosystem. And of course, it's going to miss all the dynamic testing where really the interesting things happen. So I think because of those 3 issues, we still have a significant number of apps that have security issues. So what can you do about it? The good news is that there's a lot you can do, and there's a lot of open source tools, and I'll touch on a few of them today to get you started, that you can do to kind of address some of these risks. So let me just take you through a few of these. So one of the first things that people need to do is you need to understand what apps you're using. So of course, what apps you're building and what apps you're using. Some large companies actually struggle with what apps do we build because they're multinational. And a lot of people struggle with what apps are used in my enterprise. So for my talk that I gave, I actually went out there and I built a tool open sourced it. It's on my GitHub repo. So if you happen to use Intune and you're curious, you can come out and export all of the apps that your company uses with this utility. It's trivial to adapt this for any sort of MDM, but it's really helpful to go out there and say, what apps exist inside your enterprise, get them into a CSV file, and then just do some basic analysis of what sort of apps are out there, and put them into different categories. Like, these are brochureware, this is a parking app. Oh wait, this has access to our financial system. This is Slack and has access to all of our comms. This is email, and so you can kind of break them into these different categories. So I've got a tool out there, you guys can check it out, and use that to download and inventory all the apps in your environment. A second thing you can do free that's out there is check out the OWASP MASVS project. Just like we sponsor Frida and Radare, we hired Carlos. He was one of the two maintainers of this project. He had been doing it nights and weekends, just like Ula and Pancake had been doing on their tools. And we said, look, this is a really important standard. And so he gets to do it full time now, mostly works on the open source. And they've really, really improved the mobile application security verification standard. So it's an excellent standard built on all open source, and you can go check that out and think about what you should be doing for mobile apps. And then go out and test mobile apps. I'd be happy to test a mobile app for you. That's what I do for a living. Send me a note if you'd like to. But you can also just go download MobSF. MobSF it's a good project. It's a good start, I should say. I know the founder there. He uses our product at the company that he works at. This is a project that was meant to be, hey, I want to go do something open source. I want to try a few things, but it's not enterprise ready. It's not maintained in the same way, et cetera. But you can literally just go out there, download MobSF with a Docker pull command and run it on your computer and go upload an app and test it. Now, mostly you're going to get a static analysis coming out of it. And I would say there's a lot of things that are flagged that you should be, asked to look at. There's a high signal to noise ratio, or low, I should say. So you get a lot of noise, and you got to go figure out which ones really matter. But basically, it spins up a website just running locally on your machine. You log in, and you upload your app, and it'll analyze it and bring the results out. So you can actually go through, and this is what it looks like. Let me zoom in a little. Here you go. So you'll have different findings out there, and so he'll list off every single permission and give you a description and things of that sort. So you can go out today and test these apps with MobSF. So really what I recommend to folks do is go figure out what apps matter to you. Maybe it's the apps you're building, maybe it's the apps that you use. Get an inventory, stick them in just a high, medium, and low. We don't really care about this app. It doesn't access anything sensitive. This is really important, and our revenue and customer data goes through it. Run it through a scan. Use open source tools. Use MobSF. Do a static scanner if you want. Use Frida and Radare. Those are the tools that we built bespoke for mobile app testing. And get a sense for what issues exist in those apps. How frequently are they changing? How are what new issues are being introduced over time? And then ultimately integrate this into some sort of process, into your DevSecOps process, into your MDM, so here's the new apps that are being out there, and build a process where you're kind of continuously going out there and vetting mobile apps. So to kind of pull everything together, I think that finding mobile app issues is difficult because of the platform issues that we've mentioned earlier. It's very hard for defenders and security folks to get access to the data and the telemetry that we need. Because of that, it's not a really exciting place for vulnerability researchers. There's so much work you need to do just to get started to then go hunt to find something that maybe you can get a bug bounty on or get enough visibility on. So we're just not seeing as much R&D going into that space. But I would argue that mobile apps probably impact us more on a security and privacy level just because of the prevalence of the devices and the apps and everywhere that they go with us. Apple and Google are not rigorously testing the apps you use or the apps you build. They are going to look for compliance with their requirements, but they're not going to find the types of issues that that we're outlining here in our presentation here. And that from an enterprise standpoint, best practices, you really have to be kind of continuously looking at these apps. They change so frequently. SDKs can be wittingly or unwittingly updated, and you were secure today and tomorrow you've got a big issue. So turning that into a continuous process that helps you detect those security and privacy issues will have a significant impact on reducing the overall risk into your organization. So that's it. I love letting people out early, 41 minutes. I'm happy to answer any questions though if anybody has any, or feel free to come up afterwards and say hi. Thanks so much.